Dear students, I am Santhan working as a physics faculty in Target English Medium School. Today, in the chapter of heat, I would like to teach what are the application oriented questions they are asking during the examination, and also that questions we are not discussed in any video of the heat chapter. Okay, mostly from our textbook I will be explained in this today. The first one thing is there. Okay, why dogs panting during summer? Explain with the concept of evaporation. That question is there. Okay, so generally you are observing that evaporation is which process? Cooling process. In case of human being, first we discuss that before going to the about the dog concept. In case of human being, we have the sweat glands on our skin, means sweat holes are there. So through the skin, the sweat will become outside. When the sweat will become outside, it brings certain heat energy from our body. That's why. So it will be bring certain heat energy. Then after comes to our skin surface, it will be converted into the vapor state by the evaporation. That's why we feel cool. But in case of dogs, so the dogs does not have any sweat holes on their skin, only at the foot only, means the dogs will be have the sweat holes or glands where at the foot. But the most of the cases the foot will be touches to the ground, most of the cases. That's why. But at the same way, evaporation is depend upon the surface area. If the surface area is more, evaporation is also more. But in case of human being, from top to bottom entire the skin is there. That's why you are consider the skin surface area, it will be more is there. That's why evaporation is more. Then due to the evaporation only our body temperature will be balancing. But in case of dog, when compared to their body skin, so the under the foot, the pot is very less. That's why evaporation is very less in case of dog. Then how they can reduce their body temperature? If they cannot reduce their body temperature, what will be happen? Maybe they die. That's why to reduce the body temperature, the dogs will be do the panting. What is that panting means? So generally you are observing that most of the cases during the summer season, in our daily life, the dogs will be keep their tongue into the open side and grasping. So they keep the tongue in outside and the grasping. Why they do they are, why the dogs are doing like that one means that is called panting. Why especially they are doing like that one means I says that the dog does not have any sweat holes on their skin. So that's why to reduce their body temperature. So when they are open their tongue at that time, the dogs will brings the saliva from the salivary glands. Are understanding or not? So inside salivary glands are there, so they bring the salivary gland, they bring some saliva from the salivary glands at that time. So the saliva will be brings some heat energy from the internal parts. So that saliva will becomes onto their skin, then it will be exposed to the air, it will be evaporated. That's why the body temperature of the dog will be gradually decreases, or not gradually, so it will be maintained equilibrium temperature. So once again listen very carefully. So in case of human being, we have the sweat glands are there. So that's why if the sweat will become outside on our skin at that time, it brings some heat energy from our body parts. Then so we feel the cool because of our body temperature is reduces. Due to that reason, our body temperature is maintained 37 degrees Celsius. But in case of dog, on the dog skin there is no sweat glands. That's why to reduce their body temperature, they are doing the panting. Panting is nothing but they keep the tongue into the outside from the mouth and start the grasping. At that time what will be happen? So when the dogs are doing the panting at that time, so it will be bring some saliva onto the tongue. okay, surface. At that time the saliva will be brings certain heat energy from the body parts. After it reaches to the which one tongue, okay, it is exposed to the air and immediately converted into the vapor state. That is the way of the method used by the dog to reduce or maintain the body temperature in equilibrium state. Next one is, how does the surrounding air becomes warm or cool when vapor phase of H2O is condenses? Explain. Listen very carefully. Okay, the surrounding air is becomes warm or cool when vapor phase of H2O is nothing but water, means water vapor when it is condensation. Okay, so the surrounding air is becomes warm or cool. That is, so generally, okay, we know that condensation is nothing but, okay, a gaseous state of substances is converted into the liquid state. A gaseous state of a substance is converted into the liquid state. It loses the heat energy, or it is nothing but it is release the heat energy. The releasing heat energy will be absorbed by the surrounding air. That's why here we are observing that. Okay, first of all we can write the condensation definition. Condensation means the process of changing the vapor state into the gaseous state. Okay, condensation is which process? It is a warming process. Why it is the warming process? Okay, during the condensation the substance will be loses the heat energy, is nothing but the substance will be liberate or release the heat energy. That releasing heat energy will be absorbed by which one? Surrounding air. That's why surrounding air temperature is increases or decreases? Obviously it is increases. That's why, so the surrounding air temperature is increases, means it is becomes too warm but not the cool. That's why when the vapor phase of H2O or water is condenses, the surrounding air is becomes too warm only. So, and one more thing is there. It is in a beaker. The beaker is filled with water. Along with here, in a beaker we place a funnel. The funnel we placed in the inverted mode and we place a coin here. Listen very carefully. So a beaker is filled with water or pyrex or whatever that may be. So here in this one it is slowly heated with help of the Bunsen burner, like this one where I can set that. But here, okay, in the water we can keep a, okay, funnel in the reverse mode or in inverted mode. But okay, so the, okay, large surface area of the funnel will be keep at the bottom of the beaker. At that time between the funnel and this one we place a coin, because of for allowing some air or water, whatever that may be. Now here we are observing that. So on the surface of the water in a beaker and on this one, what is acting? Okay, atmospheric pressure is acting. That is, you know that atmospheric pressure is acting. Okay, so the water which is present in the beaker and in this one, what will be acting means here, so atmospheric pressure is acting. Okay, but here, okay, in this one, in our concept, okay, the bubbles will be first of all appears where? In the beaker or in the funnel. That is the one. Okay, but the bubbles are appears in the funnel but not in the beaker initially. Why? Because of here means, okay, so the funnel mouth is very small. Okay, already in the funnel a little bit volume of water is present. That is, you know that. Okay, so now the pressure is acting on the funnel and on this one is the same. Now here, okay, so due to the lesser volume of the water here, so we supply the same heat, we supply the heat energy to the water. In this one, two concepts will be explained. Okay, first of all, lesser volume of water will be present inside, but the pressure is the same as on the beaker and on the funnel. Okay, so that's why what will be happen if the amount, we know that Q is directly proportional to M. Okay, so means not this one. Okay, sorry here. So in this one, we are observing that the pressure is acting on the funnel is more than the outside. Why? Because of means. So what is the atmospheric air is acting on this one along with this one. In that narrow funnel, some more air is also present inside. Is it correct or not? Okay. So because of due to the capillarity property, the water will be rises up to certain height in the funnel and remaining above this part, what is there? Air is there. That's why atmospheric air and the air present in this one, these both are exert the pressure on the surface of the water inside the funnel. So that's why what will be happen means, so when compared to the surface of the water in the beaker, slightly more pressure is acting on this one. So we know that. Okay, so I says clearly in the part videos, effects of pressure on boiling. The pressure is increases, boiling point is also increases. If the pressure is decreases, boiling point is also decreases. That's why here. So when compared to the beaker, only we are consider the funnel. In this one, slightly if the pressure is more, that's why if the pressure is increases, boiling point of water is also increases, then quickly the water in this one will be boiled and the bubbles will be fast appears to come outside. Okay, this is one is there. Listen very carefully. Okay, so when in a beaker, the beaker is filled with water. After that, we can take a funnel. The funnel is placed in the inverted mode in the beaker, but between the funnel mouth and the beaker, we place a coin. So in the funnel, already some water will be entered. Okay, so now when you can heated the water in the beaker, the bubbles are first we seen in the funnel but not in the beaker. What is the reason means? So the atmospheric air or the atmospheric pressure is acting initially on the funnel and beaker is the same, but above the surface of the water in the funnel, due to the narrow hole, some air is present. Okay, so this air is also exert some pressure on this one along with the atmospheric pressure. That's why this pressure is slightly more than the outside. Then what will be happen? Okay, so if the pressure is increases, boiling point of water is also increases. That's why so the bubbles are quickly we can see inside the funnel but not in the beaker. But laterally we can see in the beaker. This is the reason why we can initially see the bubbles in the funnel rather than the beaker. Next one, collect the information about working of natural geyser and give the report. So natural geyser and electric geyser, two concepts are there. Collect the information about the electric geyser, collect the information about the natural geyser. Okay, I will be explaining two cases. So here here we are observing that it is a simple diagram of natural geyser. It is the electrical geyser. Natural geyser is nothing but so mostly in the Minnesota, California, and in certain areas in the abroad countries. Still nowadays also we are observing the natural geysers. is nothing but some of the lakes or in certain rivers or in the ponds. The water will be not in the cooling mode, it is in the hot mode. Nearly, okay, so 40 to 43 degrees Celsius, like in certain areas 50 degrees is also there, but whatever that may be, so most of the cases you are observing that. Okay, so but how the water in the pond or in the lake, how they can heat it? We cannot heat that water, it is not easily possible. But how the water will be become very, how the water is, okay, hot in that particular areas, okay, means, so that is simply, okay, we consider under the which one, natural geyser. Generally we know that, okay, so in the lower standard level we know that the earth will be considered as some horizons. As we go to the deep, okay, rock horizon is there. Okay, so in the rock horizon a small tiny portions are present. In the tiny portions, okay, so higher pressure and temperature of the air is present with certain gases. Means we know that as we go to deep inside the ground, the pressure is gradually increases. If the pressure is increases, temperature is also increases. So from the Boyle's law we know that PV is equals to nRT. So then P is directly proportional to the T because of, so the volume and n moles of the gas and R is the constant. Okay, for a given particular volume, the pressure is directly proportional to the T. Means, so the pressure is increases, temperature is also increases. And also we know that as we go to deep inside the ground, okay, so in the 9th standard level in the floating bodies chapter I clearly explained. Okay, so as we go to deep, okay, deep inside the ground, the pressure is gradually increases. If the pressure is increases, temperature is also increases. That's why the air along with the gases is will be contain a huge amount of heat energy. Okay, that's why we know that the pressure on the surface of the earth is very less and inside the ground is very high. But this we know that any type of energy is always transferred from higher energy to lower energy. This way this higher pressure energy will become to the lower pressure energy is nothing but onto the surface of the earth. It will be selected one path. But how the selected path means, so which portion, okay, will be weaker region is there. Okay, in that weaker region means, it will be apply the force, okay, some force on the upper portion, then it will be easily yields, means is nothing but give the way where the weak regions or weak portions are there. That's why, so it will be apply the more force on the weaker region, then the weaker region will be quickly yields, then that high pressure along with that heat energy will become outside. Okay, so that's why it is continuously coming up to certain years. After that one, what will be happen? Okay, so the heat energy will be losses. Again the hot water, okay, hot water of the lake will be converted into the, okay, or changes into the cold water only. So this is the way of method for working of which one, natural geyser. But in case of electrical geyser, just okay, similarities are there but some difference is there. Here it is the not a man-made, it is the natural. Here it is a man-made, that is one. So this is a rough diagram of electrical geyser. It is the inlet, means cool water is enter into this one. This is the outlet, means hot water will become outside through the tap. So in this one we are using the two heaters are there. Okay, heater 1 and heater 2. So electric geyser is a device. In this device, okay, electrical energy we are converted into the heat energy. It is we are used for the which purpose? To heat the water. Now here, so when the water will be enter, okay, into the geyser through the inlet, okay, so when you can supply the, okay, current, this one, the heaters will be, okay, convert the electrical energy into the heat energy. In the heater, which elements are we are using? Okay, nichrome. Nichrome is used as a heating element in the electric geysers because of nichrome will be have the higher specific resistance is there. So due to that one, okay, so which amount of current is entered to here, that current will be converted into the heat energy. That heat energy will be absorbed by the water which is enter into the geyser inside the pot, then it will be heated and come outside. But the temperature of the water will be maintained constantly here. Why? Because of if the temperature of the water we cannot maintain constantly, the heat geyser means it is a enclosed system. That's why if the temperature is more, okay, more water will be converted to the water vapor and it will be burst. Okay, that's why to avoid the exploding of which one water geyser, we are using the thermostats. The thermostats are connected to the heater. Okay, from the electrical supply, the thermostat will be maintain the temperature balancing. Means when the heaters will be reaches to the particular temperature, means okay, heat energy, automatically the thermostat will be cut off. Means so no current will be supplied to the heater, then the heater will be not convert the heat energy, electric energy to heat energy. So that's why when the temperature decreases, automatically the thermostat will be okay on, then again it will be allow the current, then again the okay water will be converted into the heat. So this is the way of the method to working the electrical geyser. In the natural geyser we know that okay, so mostly the rock portions, some tiny pores are there. Okay, in the tiny pores, a huge amount of the higher pressure and temperature of the okay mixing of the gases are there. Okay, hot gases are there. So these hot gases are sometimes will become outside onto the surface of the earth. Okay, this type of situations we are observing in certain areas in the abroad countries. Okay, so but here okay certain areas you are observing that in the foreign countries, so the water in the lakes or ponds will be continuously heated, and also you are observing that the okay water will be, we are observing some bubbles will become outside in that lake in that particular area. In that area we are going that one, so the water will be temperature is 40 to 43 or 45 degrees Celsius is there. But who heat that water? No one cannot be heat the water, but how the water will be heated in that particular area means so due to the natural geyser. So we know that as we go to deep inside the ground, P equals H rho G. Okay, so if the depth is increases, okay, means as we go to deep inside the ground, the pressure is increases. If the pressure is increases, temperature is also increases. From the Boyle's law, we know that P is directly proportional to the T. That's why when the pressure is increases, temperature is also increases. The rock portions is okay at the bottom of that one. That's why so the temperature is more and temperature is also more. Is nothing but the gases which are present in that area will be have or contain a huge amount of heat energy. That's why this higher amount of heat energy will become outside to the lower position. In that one, it will be okay selected a weaker region. In that weaker region, it apply the force and make a tiny hole. Through that hole, it will become outside. Okay. Now, like the same way here is also. In this one, electrical geyser, okay, is a device. This device will be converts the electrical energy into the heat energy. Okay, so in the electrical heater, okay, in the electrical geyser, we are using the heating elements. These heating elements are made up of nichrome. Okay, because of nichrome has the higher specific resistance. Due to that one, it produces a large amount of heat energy. Okay, and so now here in the heater, two okay pipes are there. One is the inlet, another one is the outlet. Through the inlet, cold water will be enter and cool water, and through the outlet, okay, hot water will be come outside. And totally here two heaters we are using that. These two heaters are connected to the okay so electrical supply through the which one thermostats. When the cool water is entered to inside, okay, so when you can supply the heat energy, so the cool water will be okay means the okay when the switch is on, the current will be passing through the okay passing through the thermostat and comes to the okay heater. In the heater what will be happen, the nichrome device will be have the higher specific resistance. Due to that one, electrical energy is converted into the heat energy. That producing heat energy will be absorbed by the water which is entered to this one. But here what is the use of the thermostat means the thermostat will be maintain the balancing of temperature inside the geyser. If the thermostats are not using, then what will be happen? So current is continuously supplied to the heat energy, then the okay the water temperature is increases, and finally water will be boiled, and so higher amount of vapor pressure will be increases inside, then finally it will be explode because of it is an enclosed system. That's why to avoid the explosion of electric geyser, so the thermostats are there. When the temperature of the water will be reaches to particular one, automatically the thermostat will be cut off the supplying of okay electrical energy to the heater. So next one we are observing that mass of the ice is 2 kg. what is its initial temperature is minus 5 degrees Celsius. It is continuously heated. Listen very carefully. So the mass of the ice is 2 kg and initial temperature is minus 5 degrees Celsius. Now this mass of the ice cubes are taken into the beaker and gradually heated. And finally the temperature is reaches to the 0 and 100 degrees Celsius. During the type of condition, what are the observation you are observed? That is, we can explain with help of the diagram by taking the time and temperature values. So now here this is the graph. The time values you are taken on the x-axis in the minutes. The temperature values you are taken in the y-axis in degree Celsius. Now here it is the plus y-axis, it is the minus y-axis, it is the plus x-axis, that is that. Now let's become, what is the initial temperature of the water? Minus 5 degrees Celsius. That's why here, so for understanding of you, it is the minus 10 degrees Celsius because of it is the minus y-axis. Where can set that? So 5 means here is there. That's why minus 5 degrees Celsius we can set here. In this one, initially means so the ice cubes in the beaker is at which temperature initially? Minus 5 degrees Celsius. That's why at this point is there. Now it is slowly heated. When a body is slowly heated, what will happen? Minus 5 to next, minus 4. We know that. Minus 5 to minus 4. Next, minus 4 to minus 3. Minus 3 to minus 2. Minus 2 to minus 1. Minus 1 to 0 degrees Celsius. You know that. So when you can supply the heat energy to the ice cubes are absorb the heat energy, then their temperature is gradually increases. Means at that time we place the thermometer and clearly observing. Which thermometer we are using? Laboratory thermometer. I says that. What is the range of the laboratory thermometer? Minus 10 degrees Celsius to 110 degrees Celsius. That's why. So when the laboratory thermometer is placed in the ice cubes in a beaker, so the temperature is, ice cubes are after absorbing the energy, the temperature is gradually increases. Minus 5 to minus 4, minus 4 to minus 3, minus 2, minus 1 and finally 0. That's why here minus 5 to gradually means here the gradually temperature is increases. Then finally just you can say that after the 2 minutes, so just for understanding of you, after the 2 minutes the temperature of the 2 kg mass of the ice cubes is reaches to the 0 degrees Celsius. That is your answer. That's why the starting of the process you can set the A and this is the B point. When the temperature means so when the temperature in the thermometer is reaches to the 0 degrees Celsius after the 2 minutes, we are observing that the ice cubes will be start to convert into the water. And if you are continuously observing the thermometer, so up to rise the temperature, you are observing that the thermometer reading is not changes, or the temperature reading in the thermometer is not change or rise further even you supply the heat energy. Already we discussed that in the concept of how to find the melting point experimentally. So up to certain time, the temperature in the thermometer is not change or rise even though you supply the heat energy, because of to break up the intermolecular covalent bonds, it will be absorbed some excess heat energy up to the entire the ice cubes are converted into the water. That's why when the temperature is reaches to the 0 degrees Celsius after 2 minutes, the ice cubes will be convert or changes into the water. And up to certain time, for example, just we can say that up to the 5 minutes, means from 2 to 5 minutes it is the point to see where can say that. So after the 5 minutes the total ice cubes are converted to the water, and if you can continuously supply the heat energy, the temperature is gradually increases. We know that. So 0 to next 1, 2, 3, 4, 5 means 10, next 20, 30, 40, 50, up to which temperature? 100 degrees Celsius. That's why here just you can set that. So here we are observing that, okay, when the temperature is reaches to the 100 degrees Celsius, means after 8 minutes the temperature is reaches to the 100 degrees Celsius. It is not exact time, for understanding of you only I will explain here. If the temperature reaches to the 100 degrees Celsius, we are observing that the water is start to converted into the water vapor. But here also we are observing that up to certain time, the temperature is not changes, because of the entire the water will be converted into the water vapor up to that time. So the temperature is not rises. But at that time, what are the heat energy we are given to the water? That energy will be absorbed to break up the intermolecular covalent bonds and also increases for the intermolecular space. And after that again, the temperature is increases. So now here we will become to that one. So A is the starting point of the ice, minus 5 degrees Celsius. B is the temperature reaches to the 0. C is the starting the conversion of the or completion of the melting process, or the water will be converted to the vapor. C. Next it is the D, it is the E, it is the F. We are considering some points here. So A to B. A to B, it is represented which state? Solid state. So I will write clearly here. So from the diagram, we are observing that. Once again, listen very carefully. What is the 2 kg mass of the ice cubes initial temperature? Minus 5 degrees Celsius. That's why here we can put the dot, because of process will be starting. If we can supply the heat energy, ice cubes are absorb the heat energy and gradually their temperature increases. Minus 4, minus 3, minus 2, minus 1 and 0. When the temperature is reaches to the 0, ice cubes will be start to change into the or converts into the water. But the entire the 2 kg mass of the ice will be completely converted into the water. Up to that one, the temperature is not increases. That is we are observing. Just we consider that after certain time, the entire the ice cubes of the water ice cubes will be converted into the water. Then further, the temperature is gradually increases from 0 to 10, 20, 30, 40, 50 up to 100. When the temperature reaches to the 100 degrees Celsius, we are observing water will be start into the water vapor. Here also up to certain time, the entire the water will be converted into the water vapor. The temperature is not increases. After that, the temperature is again increased. Now here we are observing that A to B from the graph. A to B, it is represented the solid state, because of A to B in this totally what is there? Ice is there. Next, BC is represented the melting point of ice. What is this one? 0 degree Celsius. Listen very carefully. AB line is represented the solid state, means ice. Here only is there. Next, BC is represented the melting point of ice. The BC phase is represented solid plus liquid phase. In the AB, only solid phase is there. In the BC, both ice and water combined. That's why solid plus liquid. S plus L. Next, B to D. Sorry, C to D. It is only liquid state or liquid phase. Liquid state or liquid phase is there. Next, DE is represented the what is that one? Boiling point of water, that is 100 degrees Celsius. 100 degrees Celsius. Next, EF is the what is that one? It is in the vapor state. Another one is there, means steam. For that, total it is in the vapor state. Now here we are observing that in this process, B to C, it is a straight line. D to E, it is a straight line. Is nothing but here it is represented. Even though you can supply the heat energy, the temperature is does not changes from B to C and D to E. That's why what will be happen, BC is represented the melting. Okay, during the melting, which is constant, temperature is constant. Like the same way, during the boiling, which is the constant, temperature is constant. This type of observation you are observed. Okay, so A to B is represented the solid phase, is nothing but only ice. B to C is represented the, okay, so melting point of ice. Here temperature is does not changes, it is remains constant. So B to C, solid plus liquid, both phases are there. Next C to D, it is represented temperature is gradually increases, it is only the liquid phase. Okay, and C to D is represented temperature is gradually increases, it is only the liquid phase. Next D to E, D to E, it is represented the boiling point of water, that is 100 degrees Celsius. Here, there also temperature is constant, but here DE, which states are there at the DE? So liquid phase plus vapor phase, both are there. Next EF is the only vapor phase. This type of observations we are observed in this diagram based on the concept. So students, okay, so this type of questions are, only these questions are application oriented, and also we are not discussed at any part of the video in this heat chapter because of they are not included directly in the textbook. Okay, so that's why I will be explaining that questions clearly for you, and along with that one, in the remaining any, okay, questions under the improve your learning or any other things also application oriented. If you have the any doubt or if you cannot understand any question, you ask to me through the WhatsApp. Okay, then I will be give a, okay, proper explanation through the WhatsApp only. So I hope every student, okay, every day thoroughly watch the videos carefully. So when you can watch the video one time, if you cannot understand the any concept, okay, 3 or 4 times you are watching that video because of it is in offline mode. That's why you are easily and clearly understanding the concept after listening, okay, 3 or 4 times. That's why it is the one of the best advantages for every student. Okay, so those are, watch the videos carefully in your home. That's why, so generally in the classroom, okay, at a time, okay, only one time you are able to listen the, you are listen the only one time only. But in this type of mode, means in the offline mode, okay, so some of the students cannot be receive or grasp the at a time. That's why if you can, okay, watch the video 3 or 4 times, you can easily understand the concept and the meaning of the concept. That's why you can easily attempt, okay, that question when they are asking during the examination. Thank you.